Hi, my name is Dr. Carrie Black. I am a program officer at the National Science Foundation in the Division of Astronomical Sciences. And my job is to oversee the National Solar Observatory and the Daniel K. Inouye Solar Telescope. The sun is a giant ball of plasma. It is a giant ball of these charged particles, and it's in different forms throughout the sun, from the core all the way out to the corona, out to the atmosphere. So the sun is itself an entity that is made up of charged particles and has really intense magnetic field. So the entire solar system, the whole solar system, is inside the magnetic field of the sun. Magnetic reconnection is believed to be a mechanism that helps launch things like coronal jets or coronal mass ejections, and it's believed to be a process in solar flaring as well. It's a mechanism by which lots of energy can be released in very short periods of time. Now, the reason this happens is because you have magnetic field in a plasma. And what is a plasma? A plasma is a collection of charged particles, and they move around, they interact with each other, they create electric fields and magnetic fields. And the really, really, really cool thing about plasmas is that the particles interact with the magnetic fields that they create and change the magnetic fields, and the magnetic fields can then change the trajectory of the particles. The image that you're looking at here is a graphic of magnetic field lines, and their shape and direction is altered. So stuff that gets squished in from the top and bottom gets blown out the sides. That's, in a nutshell, what magnetic reconnection is. Has magnetic reconnection ever been observed before? Yes, it has been observed before. Has it been observed directly on the sun? No, it hasn't. The magnetic fields of the sun are incredibly difficult to observe accurately. It's very, very challenging. There are instruments that measure the magnetic field on the sun. Do they measure it in the kind of detail that you need to say explicitly we have measured a magnetic reconnection a magnetic reconnection site on the sun? No, and that's what Inouye Solar Telescope is going to be able to do. These really fascinating features like the jets and like spicules and solar flares and coronal mass ejections, these things all have impacted Earth. Coronal mass ejections and solar flares are the ones that people are most familiar with, and magnetic reconnection is believed to be the driver of these things. So how these structures, like these big loops that you see behind me, how they get driven off the sun and travel towards Earth and impact us at Earth. And there's also an exchange that happens between these big magnetic clouds or storms that come from the sun. When they interact with Earth's magnetic field, magnetic reconnection happens there too. And that can be a determinator for how much that storm influences Earth's Earth system. We care about this because satellites live in Earth's magnetic field. We depend on satellites. They can be interrupted by solar flares and coronal mass ejections. Our power grids can be affected by them as well. Sometimes power grids could go down, or a satellite could go offline because it's hit with one of these storms. So I don't want people to worry. You know, we have things in place. People are working on protecting our systems, but these are things that we should pay attention to. The really cool thing, though, that I think people can observe and not at all be afraid of, that's just really beautiful, are the northern lights. So, you know, these big storms erupt off the sun, in part, we believe, because of magnetic reconnection. They can hit Earth's magnetic field and cause the particles to become excited. And then you can see the beautiful aurora near the north and south poles. This is a really exciting time for solar physicists. I'm excited as a program officer and a scientist myself to get to see what comes out of the Inouye Solar Telescope. The images that we're going to see are like things we have never seen before. So on top of the amazing science, we're going to see some truly incredible pictures of the sun, and I'm very excited to see what happens with it. To learn more, go to www.nso.edu.